Starting. Okay, yeah, hack session, face anonymization. I don't know how much progress we made since last time. I think you made a GitHub repository, right? Did you also add the code, Richard, that you had for your pipeline? You said you had one.
I haven't added mine yet, but I think Archie, did you add some code?
Hi. Yes. Is it noisy? My background?
A little bit.
Unfortunately, I'm between commute, and then it's a bit noisy here. Sorry. So
Okay.
really sorry about that. But yes, what I have done is collate some of the resources around face anonymization, and as well, I played with two different public models that are available. So both the notebooks are in our repository. So
maybe I can just share my screen and we can have a look at it. I mean,
yeah, let me share. Yeah.
Or yeah, I can also share. You can also.
Okay, you could share.
Richard is sharing. That's no, I'm sharing. Stop. I think Richard, you have to present again.
You're muted, Richard.
Okay, one sec. Yeah, sorry. Let me try again. Okay, is it starting to share?
Yeah.
Okay, cool. Can you see?
Yeah. If you.
Okay, cool. Yeah, I just put together like a README and stuff. Just it's nice to have a nice README for when people come across the page. But yeah, Archie, I guess you put up these notebooks. So which one?
Maybe we can start with the resources.
Okay.
So basically here I have collated, the different data sets that's available, some of the GitHub repo that I found, and a few other information. So maybe a few pointers for the different data set. Most of them are non-commercial, except the first one, deep privacy-based data set. It comes in 4 different sizes. Some of them are non-commercial, but the smaller ones we can use, and I think they are of decent size. This is if we were to actually use them to make our own, own models. All the other data sets that I found, they're all non-commercial, only for research. Yeah. And in terms of papers, I think that the first paper, Deep Privacy, is the one that comes up again and again. And if we actually look at their repo, it's actually quite an interesting one. They have published 2. If you go down, there's another one, another link. If you go down.
Oh yeah.
Yeah, here. So here they have actually 2 papers. One is on face detection. That's the first paper, and the second one is in painting. So you could actually see in the first one they just detect the face, and the second one they use GAN to actually in paint some other face, GAN generated face. So this would I'm planning to dig through both the papers to understand a bit more. There's also a Hugging Face space on deep privacy. So I haven't played with it yet, but I think we can also dig through that to understand a bit more. So in terms of model, I think for the face detection they use mask RCNN using ResNet backbone. Yeah.
Cool. Okay.
Yeah, that's deep privacy. I think this keeps coming.
Cool.
Let me see
so
what
in
else.
In this case, we would then train the model with more data than they did. So like, if we would have additional data, we would add that, and then just like also train the same algorithm again.
Yeah.
To make it better.
Yes, that's right. That's what we can either let's say if you're trying. I think you mentioned YOLO, right? If we were to train YOLO for face detection.
It's just an idea. I mean, like instead of mask RCNN is a little bit more compute heavy, but YOLO is a little bit less.
Exactly. Because I would assume we need to also look at compute in this case, because we're going to be running on when we are trying to flash the images. So YOLO we can there are few models that was trained on Coco dataset. We can take that and fine tune using the dataset that we have here. That would be one of the proposals here. Yeah. Richard, can you flash the other notebook?
Yeah, sure. Oh, Cornea. I've used Cornea before, actually.
Yeah, Cornea actually comes with face detection that I played with.
Oh, cool. This is like a library.
Yeah, so I played with two different libraries. One is called face recognition. That's the first part. If you can go down, I try to build my own sort of a test data set. I have about 30 images now. I count the number of faces in each picture. So you can just go down. Like for example, stop. You see the second picture, it missed the face. So I'm trying to understand what it missed and what it captured. So probably eventually, I mean, this is just a proposal. Probably we will have like a test data set of 100 images where we can test not only this, this particular model, even the one that we built. For example, on some of the public data set, this one had about 90+% accuracy, yet it missed quite a few faces, So that's the reason why I'm trying to collect some of these images and trying to see where they are missing. So, Richard, can you go down? So yeah, like stop. Can you see here? Like here on the middle picture, it completely missed all the faces. Not sure why. Yeah.
Interesting. Yeah.
Yeah. You can go down. So yeah, you can stop here. Like this, there's a collage here, and then it missed everything.
Because it's quite similar to this one. It looks anyway, right?
Yeah,
it's strange.
Yeah, it's very similar, but I actually rerun a few times. I'm not sure. And the problem with face recognition is I don't get to play with any of the parameters. Later, we will see Cornea actually allow us to play with some of these, thresholds, overview thresholds, and all the others. In fact, yeah, the model itself is in PyTouch, and we can sort of fine tune them. Yeah, you can go down. This is face recognition. It's a library that I found.
Cool.
So you can see, like, I try to count the number of pictures on each images. Of course, I could be wrong. Like sometimes you see, like on faces 6, it actually picked out 38, but I only picked out 16 because I thought it won't be able to pick out. But it was really good.
Yeah. You're only working at human performance though, so.
Yeah. So next we have Cornea. Cornea is really interesting. It's based on this architecture called UNet, not U but YU. It's quite interesting. Yeah, YUNet. So this one, they also provided a bit of code to do blur the faces. You can go down and take a look. It uses Gaussian blur.
I think that might be where I got the function previously. Yeah. I'm sure there's lots of them. But.
This one actually did slightly better, but yeah. You see the picture number 2, the previous model missed. This one actually picked. Yeah.
Cool. This one isn't that well blurred.
Sorry?
It doesn't look like it blurs that well. You can still see it.
That's one of the things that, yeah.
But that's easy to fix. We've missed some here. It's a blue face anonymizer.
Yeah.
Oh, it did better here.
Yeah, this one, you see that it picked out quite a bit, but not completely.
So when it draws 2 boxes on a single face, does it mean that it has detected 2 separate faces?
Yeah, that's an interesting question that I had also. If you go one of the portraits, yeah, it has actually drawn 2 boxes. I don't know what it means, to be honest. I think here we are probably not doing the non-max suppression properly, or we need to play around with that's why probably building our own model would probably allow us to understand a bit more of the parameters.
Yeah. So for people who don't know, this often happens with face detectors. You get like lots of boxes that are very closely overlapping. So it might detect the same face lots of times, and then you do non-max suppression, which is like a post-processing step to, I guess you look at what the overlap of the different boxes is, if I remember. You look, like if a box is like 90% overlap with another one, it's probably the same face, for example. So that's non-max suppression.
Yeah, if you look, right, like for example, that particular picture that we with not enough blurring, I think there's only one box. But for those with really strong blurring, I think there's more than one box that's detected. That's why it's a lot more darker.
Interesting, yeah. This is cool, though. Really cool. Oh, they got
This also, yeah, for example, this one, the other model picked out, but in this case, this model didn't do that well. I'm not sure why. Is it because the eyes are, facing the other side? I'm not sure, but yeah, it's these are interesting questions.
Yeah. Cool.
Yeah, that's where, in fact, this model also didn't work with 3 of the images. I'm actually in the process of trying to identify why. I think that's because the probably for these images we will have to reshape. So I'm still trying to work on that.
Very cool.
Yeah. Yeah. So maybe I'll try to. Can I share something?
Yeah, go for it.
Can you see?
No.
Now it's coming.
Yeah, now it's coming.
Let me know when it's on.
Now it's on.
Yeah. So basically, I think this is what we have done. We picked out the resources and explore some of the existing model. I think this is what we have in mind. Like, the test data, maybe we'll build it to 50 and over time to 100 images. Like I mentioned, some of these models do have a very high accuracy on public data sets. So they're not giving us enough, idea of how they are performing in the wild. So that's why I thought of, building a test data set by ourselves. And then over this week, I'm also planning to get into the deep privacy, as well as deep dive into Cornea. What I'm thinking with Cornea is like if we can, get this UNet model and then sort of fine tune using the deep privacy data set, the one without the non-commercial license.
Yeah, I'll figure out which face detector worked best when I was using it before as well, and maybe we can try that one out and see how that performs. That'd be interesting.
Yeah. Then also for our own model, I'm thinking of Ice Vision. It's based out of Fast AI and PyTouch Lightning. They just, in fact, uploaded like Mass RCNN with Transformer backbone. Of course, YOLO if you want to be light. So probably we can play around with this for the week also.
But YOLO will probably have a much worse performance, I guess.
Yeah, probably we'll have to find out. I think eventually we might have to compromise between compute time and accuracy.
I mean, theoretically, we could also have just 2 versions, like one is then for people who might want to download it on some kind of a device, and they might use YOLO or something. And the other one would be like if it's running in the cloud, you then take the other one, which is just better.
Yeah.
And I mean, if the data is there, you can always like train both of them,
Yeah.
Robin, how far off are we? Like, will we be able to get a sample of what your data set is, just to like analyze the performance on that, or like, are we close to the point where we could use compute to data? Or
yeah, we're kind of close to that. So actually, so yeah, have to see when we can do that. But yeah, until then we could continue with the public data set for now. Yeah. But yeah, we're getting closer and closer. So like we now have something where we can send commands in and run computer data, but now we have to publish this. And then it's about making basically the scripts also to copy the data, that corresponds to these images then into the Docker container. So like that's that step is not being done, not done yet. But
into the Docker container. Okay. Yeah.
I mean, it has to be like we have our data in a database, so, and it has to then be also available in a Docker container. So like we do this with basically a data set that is defined on our data. Or we have all of the data in the DataUnion is basically in one big database. And you define a list, a subset of this data, and say, okay, now run the algorithm on this subset of data. So,
yeah.
But this part is not finished yet.
Okay. Interesting. Yeah. Yeah, because that's where we'll learn the most, I guess, is running the face detector on these models. Like, it's good to get up to speed on all of these public data sets, but it doesn't mean anything for your data set.
Yeah, the problem is also that these images are not necessarily all really completely annotated, so that's also.
Yeah, exactly.
I mean, the people have not annotated all of them, so like it's also like it doesn't. You cannot really then check whether it's correct or not, and as you are then not allowed to look at the images yourself, so like then it's like if there's no annotation, you cannot really determine whether your algorithm worked or not. So this, yeah, but I mean, like, so in the longer run, of course, we will then have the mobile app. Then there we will show the images in a way, like then the people can see the images for annotation purposes. That's where you always have to see it. I mean, there's no way around that, but this is still taking some time. So
yeah, what will the process be like for that? Because like we just did with the face detector, the way that you figure out how well it's performing is to go through it like sample by sample. But of course, we won't be able to do that with a private data set.
In a way, I mean, like when we're building up this data set, there will be people who do that. So like we kind of do then these missions. So like for this algorithm, we could then put it in something that we call Play AI. So like you then ask to upload an image to see whether the algorithm can detect it correctly. So you basically take an image of your face, or like somebody that consents to have his face image taken, like or wherever you get the data, basically. So I mean, in the end, it's like this, and then you put you say, okay, in this image we have a face. You then annotate it, and then other people look at it and then see whether they also consent that this is correct, and then the algorithm is applied, and then basically the people then look at the result from the algorithm and then say, okay, well, no, it's not correct, or it's correct, or something like this, So then this is then basically such a challenging mode. So like that's where I think things will get really interesting. So I mean, that's basically one of the goals that we're really working towards. But the mobile app is not. I mean, we have the mobile app already, the UI, but the API stuff is the backend, and our backend is not completely finished. So there's a lot of So like basically, somehow we have an asynchronous worker framework, so that basically then detects an image is coming in, which is then like has then this tag. So like we look for these images in our database all the time with an asynchronous worker. Then they see, it's like we found one with this tag. So now then they have to give it over to the algorithm, And this part with the algorithm part, this is also not finished. So like there are still some construction sites on our side, but yeah, it's just. But yeah, like that's just the way it is. But I mean, like if we come to something that really works here, maybe we can also extend the data set. So there's this one from Google. I mean, that's also that you really looked at, right? So that's the one that you took from the good privacy.
Yeah, the one that doesn't have any labels, right?
Okay. So like I think that Google made one specifically for very difficult labels. So like maybe this, I don't know if this is non-commercial or commercial. I think it's going to be interesting if you could use that. I don't know if it's. I mean, what we're doing here is it right now? Is it already commercial or is it not commercial? I mean, we're not selling anything right now. So at the point when we sell something, then I don't. But I don't know. Like that's just a matter of moral ethics, right, in a way. So I think there are lots of models around used in the world which have been trained on scientific data, because after it's trained, how can you prove that it was trained on some data? It's like, but that's a moral conflict.
I've seen it happen in companies. So
yeah, me too. So like all the time, like selling algorithms for thousands of dollars, and in the end, it was all trained on public data sets, because they kind of know you cannot really prove it, So
yeah. Cool. Yeah, I guess. Yeah, like that's really good progress to see in 1 week, Archie. So thanks for putting all that together. I guess we're still getting like all of the processes and stuff in place. I think that's going to be one of the really interesting things about this series is like how the data scientists interact with the data labelers and what are the processes around this. So like maybe we suspect that an image is badly labeled because, you know, 4 or 5 different face detectors all think there's no face there, but it says there's a face. So then maybe we could flag and say, okay, this one really needs to go back to the data labelers to confirm and things like that. So it's this interaction between the labelers and the data scientists that I think will be really interesting.
Yeah, so that this is also something that we basically wanted and offer with our platform, is that you can make bounties, you know, so like you can say, you go into the data portal, you find the data that you are interested in, or like you can also upload it then directly, specify it, and then it becomes a mission. So like then people in the mobile phone will see it, and then are asked to complete this mission. So like, yeah, labeling it, checking it, verifying it. So like all of these are options. And then basically you get the results back from that.
Yeah, and this is where I don't know if you saw our DAO scripting or the Turkit scripting project that's going on. We funded it. It's basically like, do you see Turkit? It's like a scripting language for crowdsourcing from Amazon Mechanical Turk. But like never before has it been like scriptable. So we could write a script that says, you know, crowdsource 100 images, train model, check if labels are if any of the labels from 5 different detectors are the same. We can check if the human labels and the detected labels are the same, and then you could like send that back to get, you know, crowdsource a label again. But you could basically have a language around all of that rather than doing it manually, which I think would be really interesting to explore once that's kind of ready.
So I mean, we also going to, I mean, for us, all of this will go through APIs, you know, so like then this scripting language could also be connected to the APIs from DataUnion, and which will then be connected through this through our backend again to the mobile app and stuff like this. So like,
it'd be super cool to try and connect that. I'll send you a link to that proposal from Algovera Grants because I think you'll be interested in it. And we funded it, and Nassim's great as well. So I think that could turn out really nicely. It could be a cool project. But I think you have to run, right, Robin?
Yeah, I have my next meeting and then the next meeting and the next meeting.
The quick catch-ups are good, but yeah, let's keep chatting async and stuff in the channel. I think that like it's great to just keep chatting offline and communicating. So,
and I think the big important part is now about determining more data, how it will look like and stuff. So
I think so. Yeah.
All right. Awesome. Yeah. Then I will send the recording through, and then
I'll put it up.
Great weekend, everyone.
Thanks, everyone. Have a good weekend.
Have a good weekend. Bye-bye.